Look at that. Super nice, right? I really, really love Parallax. It's one of my favorite things to do in games, and I'm really proud of the result. Welcome, pals, to another video. Today, we're going to be talking about parallax backgrounds in 2D games, and specifically pixel art games. It's a topic that's, like last week, very near and dear to my heart because I've spent a lot of time making parallax background solutions and backgrounds in my games. So today we're going to be covering how to build all of that. I'm also going to do something a little bit different today, and maybe if this is successful, we're going to be continuing this. I'm going to be releasing everything that I make today on itch.io for you to download. For patrons, it'll be free, and for everybody else, it'll be available for a really affordable price. So, parallax backgrounds. Okay, so first question is, what is parallax? Parallax is a really interesting phenomenon that happens in the real world. Whenever we are looking at things or multiple things that fade off into the distance, as we move our head left and right, objects that are closer appear to be moving faster, and objects that are further away are sort of stationary in the background, and that depth effect is kind of what parallax is. It was originally coined as a term, I think, when talking about astronomy. In parallax backgrounds for 2D games, what these are multi-layered sprites, so multiple sprites with some Z depth difference that move with the camera to give that same illusion of depth. So here we have a little graphic that gives us a pretty reasonable explanation of what's happening in parallax. You can see at our sort of screenshot one here, we have the character, he's standing among some trees with some city and forest in the background and the mountains, and these all appear in the game at different layers. Now, each of these parallax layers move at a different speed or a different ratio relative to the camera. So the things that are close to us don't like catch up as much as the others. So things way off in the distance catch up with the camera, and they move at a rate that is almost 1, it's close to 1. So for every 1 unit the camera moves, stuff way off on the horizon moves almost 1. But stuff much closer, like these trees here, they move at 0.5, for example. And that means that if the camera moves 1 unit, they'll only move half the distance. And so if we walk, past the town a little bit, you can see those trees have been left behind. We see a little bit of the town, some of the forest, and still most of the mountain. It almost looks like the mountain hasn't moved at all. We can describe this as like a simple rule. Basically, the rule for any parallax layer is you take the origin, so the starting position of that sprite when the level loads, and you add to that the amount that the camera has traveled multiplied by the parallax value of that layer. So you understand what these first two things mean. The last one would be parallax. So how do we actually get the parallax value? How do we determine that? We can quantify that as things on the horizon, so things infinitely far away from the camera, move at a rate of 1. Things that are in line with the subject, so the player in this context, if the camera is watching the player, things that are on the player's level in the midground are moving at a rate of 0. And interestingly, things that are actually closer to the camera than the subject, so things within this space, actually move in a negative parallax value. As you move infinitely close to the camera, you approach -1 speed. That means for every unit that the camera moves in one direction, we move 1 unit in the opposite direction. We're actually moving sort of twice the speed in the other way. Here are a couple of examples from different games. I really like alpine regions, so we've got some snowy mountains with alpine trees here. And the first example here is from Chasm. It was a game that was released a couple of years ago. It is a beautiful pixel art game, and you can see there are a few different parallax layers here at play. We have the background, so the mountains. We have multiple layers of trees, which get more clear as they approach the camera. And we have our foreground or middle ground, where the player is. And you can see here that there's really no restriction on how many layers that we have. We can have as many as you want, although for the sake of composition, you can tell that the layers that are in the middle, and as they sort of head further into the background, those layers tend to be less detailed. Here's an example from a classic video game on the SNES. This is from Donkey Kong Country. And it's another snowy level. You can see the foreground, it's very detailed. In fact, Donkey Kong Country is not a pixel art based game. It's actually based on 3D models that have been sliced up into 2D sprites, and then those sprites have been, imported into the game. So everything kind of looks like it's low resolution 3D, which it is based on. You can see here very detailed textures here. There's a tile set for the underneath the snow. We've got our layer that the player is on. On this same layer are these trees, so you don't have to have every single thing on its own layer. Some things that are in relative proximity to each other can stay on the same layer. So all of these trees, even though there's distance between them, right, between the stuff in the background and closer to the camera, it's all on one layer, it all moves at the same speed. The parallax effect, it's one that you can get pretty liberal with, and the eye can still accept what it sees. In the background, for example, we have a lot of range here between these trees that are sort of off in the midground and the mountains way off in the background, and that all moves on one layer. You can see those 3 layers do a lot. You really get that perception of depth, and especially I think the trees in the foreground versus the trees in the midground, so these ones here that are on the tile set and the ones that are actually further behind, give a really nice sense of depth. You can see that the stuff in the very, very background either doesn't move at all or moves very slowly. And we have a nice effect here where the actual last background layer gets grayed out as we head further off into the level, as if we're sort of moving through a snowstorm. But at this very, very beginning layer, you can see the mountain looks pretty much stationary. That said, it is a looping texture. If we were to take this texture here and copy it across, you'll notice that when we get right to the edge, it does loop. And this is a really, really advantageous and sometimes necessary aspect of parallax, because what happens when things move outside of the view of the player, they have to loop. You'll find that I think even this second layer will loop. Let's have a look. It does. And this is what allows us to get that reuse of those beautiful textures across the entire level. Donkey Kong Country levels are really, really big because the motion is so great. So one really, really important aspect of parallax is the idea of infinite scrolling. So infinite scrolling leads to looping backgrounds, and all that really means is that when something leaves the camera, it is replaced by the same texture as soon as it leaves the screen. Looping textures don't have to be the size of the screen. That's mostly just for backgrounds. In actual fact, the rule for looping anything is something that I derived myself, and it looks like this. Basically, you have your texture. When the texture leaves the screen, it must leave the screen by half of its width at the very least for it to be off screen. So if this is the center of the transform here, the center point needs to be off the screen by the same amount of half of its total width. And then rather than replacing it at the last pixel, you have to replace it half of its width off screen further in the opposite direction. So the distance between these two objects, even though they loop perfectly, right, when one leaves, the other enters, the distance between them is not one screen because they share the same central transform, which is here and here, and that distance is half plus half the width. So it's a full width between them. So that's parallax, that's infinite scroll. Shall we make some stuff? Let's do it. Okay, so parallax backgrounds are reasonably straightforward. They are merely sprites with layers, and here we are in AEST Sprite. What I like to do before I get started is actually set this to tiled mode on the x-axis. What that means is that whatever we place in the scene will be replicated at least once on either side. So our actual canvas is, yay big, but we get a duplication of it on either side And this just allows us to have this really nice tiling situation. It might be interesting to have this be like a nighttime alpine scene, or yeah, nighttime would be interesting. And I might just use the shader tool to create a nice night sky in the background, just using really nice big strokes here. And I might see if I can add a color here. What tends to happen is if you're using a palette like I am, I find that it makes the most sense to extend that palette whenever you're doing a really high resolution or high fidelity background. That's the only time it really makes sense to do that. It allows you to have more subtle differences between your colors, just for these really, really far off backgrounds. And I'm basically going to use just one color here. Just the single color ramp, it's all blue. And keep in mind, before we really start getting too deep into this, it's really important to make sure that you know where your player is going to be in this scene. If we know that our foreground is here and our player is, you know, yay tall, then it makes sense that we don't have the background encroaching too far in. And what I like to do is, rather than have these backgrounds be just straight banded like this, I like to dither them with clouds. Start creating some cloudy shapes and let this be more undulating rather than having it be so flat. And what's great about this is that we don't really have to be looking at any one point in this tiled setup. We know that the end result will be tiled perfectly. So you can just go to town and just be really nice and free with your placements here. And to avoid the sprite looking like a repeating texture, it's important to use lots of varying sizes in any of your repeating patterns that appear in that texture. So I'm using these sort of cloud shapes, but you can see the cloud shapes themselves are of varying different sizes and shapes. And I think I want some more diversity here. Starting to take some shape now. And I'm just using these nice big circular shapes, really. It's quite straightforward. The idea that I usually sort of go with in my mind is, you know, I have some shape, and then that shape is invaded by another smaller shape that's the same series of pattern, right? So you can see here we've got like this color here and then this color here, but then it gets sort of broken up by this smaller color. And if you want to go even further, you can try to identify, I like these little like seagull shapes, right? Almost like a bird. I use those to highlight in the negative space these circles here that make up the cloud. That gives it a really nice sense of depth. You just got to keep stepping back every now and again and just looking. I think the biggest thing with this is contrast. So just making sure that, you know, it's fine to have this really dark black, but how then do we break it up? You know, how much of the overall pixels does it occupy? And how many details are there that sort of make their way through this contrast? You know, having this here creates a really focal point for your eyes. Your eyes really want to look at this because you can see there's a really, really light area right next to a really dark area. Whereas areas like this that are more gradual don't attract the eye quite as much. And our goal here for this very, very background layer is to attract the eye as little as possible. So I'm actually going to make sure that there are no dark pixels touching the sky here. And I think I just want to break this up a little bit. It looks like one big monolith of clouds, which I don't like. Keep it nice and separated. And you can see, I like to just create zones and then work them back. It's not the situation where, you know, every time you place the pen, you have to like keep that. You can just add stuff, take it away, add stuff, take it away. It's really free, you know, it doesn't cost you anything. So just layer stuff down and see what happens. So the goal for this, low contrast, one color ramp, add colors if you need to, just between your tones to keep it nice and soft. And we can even, we can even add another color here if we want. We'll just go to even more abstract cloud shapes. This layer of clouds, this very furthest back layer, is really just one bit. You can see there's only one color that separates it from the sky behind it. So once we're happy with that sky, on the same layer, we can just focus on the mountains in the background. And what I'm going to do here is create some kind of an idea of there being like a light source. Maybe the moon is behind us on the left side. So that's where I'll think of the light source, and anywhere that I see a slope heading right to left, downward, I'll put some light there. Nice. And then what I'll do is I'll just make this line more broken up. And I like to creep the line over this way. And since the moon is above us looking down, we can even get really nice and sharp with some of these details here, just to highlight those caps. Especially if they're snow capped, we can add some white in there, we could do plenty of stuff. And you'll notice areas where we move from one color to the next across one pixel like this don't really look that good. They look kind of blurred. So if you're gonna have a sharp edge, go for it. Don't do it halfway. Doesn't look very good. And don't forget, there's some depth here, so you might have some edges that aren't, they don't reach the horizon here, but they're still part of the mountain range. Nice. And maybe this glistening kind of color can be snow. Maybe we can go a little further with some of this and add one more color at that very peak there. Just a couple of pixels. So now let's take a little bit of a leaf out of Donkey Kong's book and have some trees on this mountain range heading towards the Middleground. Nice. So now I'll just make sure these are nice and pointy because they are pine trees. And giving the edges here, where there is a little bit of detail, some of that contrast and attention is what's going to really make this stand out as pixel art and not just, regular kind of art. All right, these pixel choices that we're making right here, that's what makes it pixel art. It's typified by these repeating shapes. I think that's the thing that really, really sells it. Thinking about having maybe these little jigsaw edges like this, these sawtooth edges. At the end of the day, it's a very minor detail, but it'll go a long way in just selling the overall effect. And it can really help if you use a brush that's like this shape, then you can get really quite nice tree shapes just by dragging the brush left and right as you come down. So if we were to use a square brush, it's much harder because you can't really get those sharp edges, but the 3 size brush is like a plus sign, and that actually gives you a lot more control. You can almost use it like a stamp. Beautiful. So that's our background. Now let's move on to Middleground. So on a new layer, what I'm going to try to do is go for darker colors in the middle, and then as we get to the foreground, really brighten them up. I'm just going to drop in some nice trees, and I don't want them to take up all of the space along the horizontal axis, because then you can't see what's behind it. The idea and the whole point of the parallax is that you're watching things move past each other. And even this layer, remember, will not be the last layer. So you want to thin it out, make sure it doesn't take up too much space, and use the same overall patterns that we saw in the previous layer. So even though we're not using the same brush, we're still sort of making a lot of those same shapes. And try to make these trees at least look like they're in the same plane of distance. So don't draw trees that are only this small next to trees that are this big in the same layer, because we want to stay in the same sort of ballpark Like I said, the eye is pretty forgiving, but even then, you don't want to test it too much. So some of this we could explain away as being, undulating terrain. So, there's a hill here maybe. It doesn't have to be that these trees are necessarily much closer than the others. They can just be higher up. And it can be nice sometimes to just pick a different color, like I usually do when I'm animating. And the point of this is to just give your eyes a bit of a break. These subtleties in the tones can be quite hard to look at after a while. So doing something like this can be a bit of a help. And we know what shapes we're mostly looking for, so it doesn't really matter that the colors are off right now. Again, we can use that 3x brush to get some really interesting shapes. And I really don't want you to go too far on this one just yet. The reason being is I'm going to take this layer and the layer in front of it and keep them on a very low detail so that we can apply them into the game and then finish them off. That's the process that I want you to take. That looks good. And then next layer up. So not really even choosing the color that we want. We're sort of just blocking out some shapes, and I'm going to try to make these ones quite large. And these are full-size trees, right? These are in the foreground. We can really see them. They've got lots of gaps between them, so we can see the layers in the background. Maybe they've got some branches that are all off kilter, so we can really see the cracks between them. As we can see those like really low fronds fanning down. And I imagine we will have like a second color here. I'm not sure if we'll backlight them like this or do the opposite. So you could take the inverse and light them like this. No, I think the contrast is better. Yeah, I'm using the shade brush here to not muck up any of the work. So those are our layers. Let's now take the very, very foreground layer. Maybe we'll go for some snow. And I imagine this would be, for you, probably like a tile set, something like that. Might be nice to even have it be a bit darker here, with like the lip being the bright part. So the part that's sort of approaching here. And then behind, cool. And then we can even go underneath. Cool, that's looking really good. So we'll save this now. And the next thing is I'm going to break away from the art for a bit, and we're going to go straight to programming, and then we'll come back to the art and finish it. The reason for this is I really want you to appreciate the fact that this process is one that is iterative, and it should be a conversation between your engine and your art program, so that you're going back and forth and seeing what feels right in the game, and yeah, trying not to spend too long in a space that isn't the final destination, so that you don't accidentally go way off course, then put it in the game and realize, oh no, it doesn't work. Okay, so it's Sunday night, I'm editing the video. I've decided I'm going to show you all of the art first and then all of the programming, because that makes way more sense. But just suffice it to say, I then went and did all the code, and I'm going to show you that at the end of the video. Okay, continue. So here we are back in AEST. Let's go ahead and give some of these trees some more detail. I really liked how they looked in the actual editor, so I'm not really going to make any major changes, but what I would advise if you were going to make any changes is the things that you want to look out for are just to see, like, if your foreground tiles are obscuring the stuff in the background so much that you can't really appreciate them, then I would thin them out a little more. It's just stuff like that. My approach here will be to do a kind of two-tone dithering effect. So we're actually going to see, the color go from this brighter color to a darker one in the middle. But this middle color will be, for the most part, not banded like this. We're going to use our good old environment shading technique to dither our way there. And let's get the silhouette right first. And we want to bias our left side because that's where the light source is. So I'm just going to use the right side. I'm going to light it just a little bit less. So we still see all those shades, but the left side has a bit more going for it. And give it some of that shape back at the layer level so that we don't have it be a nice big block. And it can be beneficial to just add a layer between what you're working on so that you can see it as its own thing. Sometimes it can be a bit hard, especially when you're going for something really subtle. As you layer the things down, they sort of start to blend, and again, your eyes lose the ability to really tell what's going on. So this is just a nice way of just creating a, just a temporary layer that we can use to differentiate what it is we're looking at. Just going to try a slightly different technique here. That was pretty quick. Dramatic tree drawing this music. We could go up, so we could go like this, into this if we wanted. Or even just, I think it's too much. I like it, I just don't love it. We could just take this and just kiss the bottom of these with some light. In fact, what would be really good is if we did that with snow. So I'm just gonna like drop in some snow and then shade above it. And it might be nice to add another tone to this. Cool. You want to make sure that your lighting is about the same as the tree that's underneath it. And another way you could probably do this, if you wanted to be really clever, is to take that tree that's underneath it, cut it, paste it on the layer above, and then change all of its colors. So you could say this becomes this, and then this, and then this, and then you would just erase from there. I think you get a different effect doing it like this, but still kind of interesting. The lighting will be correct, at least. You could just use it for the beginning if you want. Just don't make it too obvious, that's all. Snow is a different texture to leaves. So, that's the front. If we want to do any work on this back layer, we can very quickly, add just a little bit of something. We don't really want to give it too much. Yeah, very nice. So let's assume we were happy with this and we were ready to go. We could take the same approach we took before, export this as 0, export this as 1, and now we can have a look, see what that looks like. Whoa, really nice. Okay, I'm back. Long story short, I was going to end the video here, but I decided I didn't want to do that. So I'm going to finish the rest of this, and then I'll show the implementation afterward. Okay, I'm just going to drop in some grass here, just to iron out the separation, simple lines. Just to recap on this process, obviously, the way we're going about this is I have a big triangle, shape, and that shape I am, filling in and cutting into like this, and then I'm winging out these bits a bit more, right? Just trying to create some more interesting shapes, and then a base on the bottom. That's pretty much it. Give it some 3D aspect, sweep some of these shadows down like this, and then fill them in. That's the basics. The rest of it's just detailing. I'm really happy with how this has turned out. Honestly, I think this looks excellent. It's not perfect, but I would be happy to have this in a game. Okay, it's probably worth us doing a little bit of work on this, at least. And all we're going to do is take these two colors and blend between them. Just a little bit more carefully, really. We did do that in about 3 seconds before. Speed painting is so fun. You just get results so quick. just clean up some of these blobby shapes and we're good to go. Cool. So the next thing we want to do is basically add some detail to this situation over here. I'm following this undulating lightest color, and all I'm doing is finding little interesting shapes I can create along this seam. And what that's going to do is give me the guide for where the light should go. And then everywhere where this is sloping up this way, I'm going to fill that in as a dark shape. So I'm going to take these two colors, go into my shader brush, and just drop straight down from there. Anywhere that we see that. So this is fine. That's going down. Yep. And we can even start splitting it away. So now, anywhere at the top edge, I'm just going to do this. Anywhere where we see these shadows. Keep it nice and simple for some of these. Work it back. Just defines those edges a bit better. Cool. Here, all I want to do is keep these shapes a little more, like convey that this is receding into the background. So we've got like at the very, very bottom here, our shapes are kind of round looking, and then they go flatter and then closer together and flatter like that. That'll look like it's got some sort of depth to it. So that's what I'm doing here, like making our shapes become more flat. So it looks like this is fading into the background there. Even though it's not that far, it still will give us a perception of depth. Okay. Boom. And there you have it. Our finished parallax background. Now, I'm actually going to throw you guys a bonus here. I've shown you parallaxing for backgrounds, but I haven't shown you anything in the foreground. What I like to do with this is take just the darkest color, right? Like a black or something like that. I don't know what else you would choose, but black is good enough. Let's go from the bottom. And this is your opportunity to tell the player's eye about the kinds of detail that they're going to expect over here. Mostly though, I do it with things like rocks and stuff that's in the foreground, but here we don't really have that kind of scenery. So these are our super duper foreground elements. And now what we're going to do is put it all together in the scene. Look at that. Super nice, right? I really, really love parallax. It's one of my favorite things to do in games, and I'm really proud of the result. Now, if you're looking for an explanation on how to do this, stick around and I'll play that now. So here we are in Unity, which is my engine of choice. I'm using Unity 2020, although this will work in any version, I believe. So the basic idea here is that we have a 2D scene. Now, Unity's scenes are all 3D, even if you're using 2D. So you can take the camera here and see that there is a 3D projection, even if when we press the number 2, that switches back and forth between them, even if the game will always be appearing in this perspective, the data of that Z-axis is always still there. So the first thing that we're going to do is export our sprites into the project. And the way we're going to do that is I'm going to take each of these layers, 1, 2, 3, 4, and I'm going to hide the ones that I don't want to export. Press Ctrl-Alt-Shift-S, and then I'm going to give them a name. We're going to name these from 0, which is the very furthest back, all the way up to the front. So in this case, we can just call this 0. And make sure that we have a destination set inside of our project directory. So this is inside of our Unity project under, I like to use the folder Sprites for my stuff. So Alpine Parallax Background 0, that's what we're exporting this as. Export. Then I show the next one. We're exporting the visible layers. So that's what I do. and we're going to call this number 1. So what that does is, if we look in our sprites folder, now you can see each of our layers here, nicely imported. I want to import all of these with the same setting, which is to make them not bilinear filtered, point filtered. That lets it be pixel art. We also want to make it in RGBA 32-bit format, which affords for alpha. And if we apply this for each of them, then we can drop them into the scene, no problem. So the first thing I want to do is take the background and just plonk it into the scene. If we set this position of this sprite to 0 and 0, it will fit in the scene perfectly. So this is basically our camera looking at our sprite, and you can see now that because the camera is orthographic, it doesn't matter how close it is, the sprite doesn't get any bigger or smaller. That's how we know we don't have a perspective camera, and that's why we need the parallax in the first place. What I want you to do is set your camera up such that the size of the camera is the exact size of those dimensions. And the way that we do that is we take the height of the sprite. The height of the sprite in this case is 180 pixels. Divide that by our pixel to world unit scale. So in this case, I've got a scale of 100. That gets set here. The default pixels per unit is 100, so there's no reason to change that. So you have 180 pixels tall, divided by 100 gives you 1.8, and then half that. So that's 0.9. That's the size of your camera if you want to do this perfectly. So 0.9, the pixel art would look now perfect in the scene. Nothing is getting distorted. If we had our sprite set to bilinear filtering, then we would notice we'd get some really odd and weird blurring when we scale this up to something like 1080p. So to avoid that, make sure we point filter. Now it looks good. So we'll switch back to our original resolution. There we go. And what I want to do here is basically create our parallax object. So we're going to add a new script on this. I'm going to call it parallax. I've already created it in the scene. And that's going to be our base kind of parallax object. Like we said in the intro, the goal for this is to move by some distance when we move the camera. So let's write that up now. Okay, so here we are in Visual Studio Code. This is our parallax script. We are going to be writing in C#, obviously. So there are a few things that we needed when we were plotting this out. Let's see if we can remember. We needed an origin plus the travel of the camera multiplied by some parallax value. Those are the relevant variables in this problem. So we're going to make sure that we have space for them here. What that means is the following. First thing we're going to do is create a public reference to the camera. I'm going to call it cam. Then we're going to have a public reference to the subject, or the thing that is the player in this case. So it's a transform and it's going to be called subject. So the next thing we want is the start position. This is not a public variable, it's just a variable. So we're going to have a vector2 called start position. And I'm saving this as a vector2, even though this object has a 3D variable for its position. I'm going to save the z-axis as a separate variable. So we're going to say float start z and keep that separate. Now, we're going to define our start function. This is basically the setup, and it'll run once when the game starts. And we're going to say start position equals transform.position. This is the position of the object. We're also going to say start z equals transform.position.z. So because this is a vector2 and this is a vector3, what's happening is the third axis of this vector is getting chopped off when it gets saved into start position, because it's only going to save the x and the y. That's why we're going to store the z separately. We're going to be doing some vector math inside of the update function, but it's all 2D math. So that's why I'm saving this as a 2D, because I don't want to be casting back and forth between vector 3 and vector 2. So the next thing we want to do is define a couple more variables. These are things that are going to be updated every frame, and I'm going to save them in what are called properties. They're kind of like functions, but we treat them like variables. So they're variables that we calculate every time we call them, basically. That's how I like to think about it. One is travel. And the other one is parallax vector. Now, the way we set these is we have equals, and then we have our little arrow. This basically says that what comes next is going to be calculated every time we call this, and it's going to be read-only. So we can't set this inside of the code. It's going to be set right here. And what it's going to be is we're going to cast to vector 2, the camera dot transform dot position minus the start position. Okay, so this is the distance the camera has moved from our original position of the sprite. So before we define our parallax vector, let's get this running. An easy way to do that would be to just have our public void update loop, and we're going to say transform.position equals start position plus travel. Okay, now this obviously isn't going to be the parallax yet. All this is going to do is move things at the same speed as the camera. So let's just make sure that's working first, and then we'll go to the next step. Now, this script that we just created has two public variables. One is the camera, which we need to supply, and the other is a transform for the subject. Now, we don't have a subject in the scene yet, so drag in the sprite of your game's character, or literally just any sprite if you like. So I'm going to drag in Armin. Here he is. He goes in that slot too. Because I don't have any code here that's going to move the character around, what we'll do is I'm just going to make the sprite for the character a child of the camera. That means that if we move the camera around, the character's going to move with us. This is going to make it look like we're playing the game. If we press play, then the background should follow us around. If we drag this left and right, you can see the background is chasing the camera around perfectly. If we were to use like a fake parallax factor here, let's say it's 0.9, then this will follow along in such a way that it gets left behind by the camera as we move left and right. There we go. It's still mostly following along, but it's getting left behind a little bit as we move. This is the basis of the entire parallax effect here. But hard coding this value of 0.9 is kind of clumsy, and it's very, it's going to get really prohibitive to add lots and lots of layers and try to calculate the value for each of those. So I'm going to show you a way to do that without any numbers at all. No magic numbers. It's just going to be nice and simple. So remember, at the beginning of this tutorial, we had a model where we were talking about the horizon and the camera. So the distance that our object is from the subject to the horizon, or from the subject to the camera, that defines this value here, which is our parallax value. Now, the horizon is an infinite distance away, and the camera, our proximity to the camera is also something that we don't really have straight off the bat, because we don't really know the bounds of the camera. So there is a value that we can actually use that will stand in for the horizon and the camera's eye position, and those are the clipping planes. The clipping planes define what the camera can see. The default value is 1000, which is really far away. What I'm going to do is just bring this like way the hell in to something like 50. Okay, it's not going to change anything in the scene. It just means that anything outside of 50 units away from the camera won't be visible. And the near plane, I'm just going to set to 0. Anything that's exactly where the camera is visible, and anything that's up to 50 units away is visible. This will be our horizon. This will be our camera's eye position. Now all we need to do is factor in the distance of the sprite from those two values. So the parallax factor is a product of a couple things. The first thing we need to do is find out the distance from the subject. So float distance from subject equals, this is the distance to the player, and we supplied that in the inspector, so we already know that subject is going to be not null. So we're going to write transform.position.z minus subject.position.z. That's our distance from the subject, and that's okay if it's negative too. So we want the sign as part of this. We don't want the absolute value. Now, the other thing that we want is the closest clipping plane. What we need to know is, are we going to use the far clipping plane or the near clipping plane as the thing that we are factoring the distance between? Because if we're further away from the camera than the subject is, then we want to use the far plane. If we're closer than the subject, then we want to use the near plane. So it's just, if we're this, we want to use near plane. If we're over here, we want to use the far plane. The reason why we want to do that is to cover the fact that things that are nearer actually move in that opposite direction. So there's a bit of a different amplitude on the parallax factor if we're closer than the player. So that's pretty straightforward too. All we're going to do is say float clipping plane. This is the Z position of the clipping plane, and this equals the following. Transform. So it's the camera's position plus, and I'm going to add a ternary operator in here. So this is the distance from subject. Is this number greater than 0? If we are greater than 0, then we're using the camera.far clipping plane. And if we're not greater than 0, then we're going to use the camera.near clipping plane. So it's the camera's position plus either the far clipping plane or the near clipping plane. So now we can define our parallax factor. All we need to do is float parallax factor. And the answer is mathf.absolute value of the distance from the subject divided by the clipping plane. That's it. So the only thing we need to do now, once we have our parallax factor, is just make sure that we're not resetting the transform position's z-axis every time, right? So we're going to call this vector2 new pos, and then we're going to say transform.position equals new vector3 new pos.x new pos.y and the starting z. Now this will work exactly how we want it to. So let's drop in a couple more sprites and see this in action. We can just place them now where we want in the scene. So this one here is right where the player is. Number 2 is probably a little bit this way. 3 is a little bit further away, but not too far away. And our horizon is basically all the way out here. So this is what it looks like in 2D. This is what it looks like in 3D. If you want this to be a little more convincing, we can take our sprites, we can set them to tile mode, and then we can stretch them way out. So there we have it. Pixel perfect parallax. Now, before we close this out, I do want to let you know that there is a way to achieve a looping effect without tiling. I'll let you download the asset and have a look. I hope you guys have enjoyed this new kind of direction, going in a little bit more technical depth, and I will see you in the next one. Thank you for watching, and happy parallaxing. Hey pal, thanks for watching, and thanks most especially to the patrons and Twitch subs who support this channel and my game dev project Insignia. To find out more, click the links in the description below. And if you like this video, tell YouTube by clicking the like button, and then YouTube will tell me, and then I'll make more videos. That's nice. Thanks again, and until next time.